in these notes, I'm going to go over topic 10.6, angles and arcs in circles. We have three cases. Case 1 is where we have the angle created so that it is inside the circle. Case 2 is where the angle is on the circle, and case 3 is where it is outside the circle. So if you put an angle 1 right here and like X and Y, we have case 1, and then in case 2 we have angle 1 here, and here is X. And case 3, it is outside the circle. So I'm going to put angle 1 here, and we have X and Y. And Y is the arc right there, and X is the arc right there. X is this guy, and we can even have Y for the outside bit. And then we have X and Y right here. Okay, so for case 1, we have two, they can either be known as secants or chords. Basically, we have the segments like this, where they intersect inside the circle. If it is on the circle, or in the circle, I should say, then the measure of the angle is formed is equal to half. Remember, the angle is always half of the arc. We learned that last 2 classes ago when we talked about inscribed angles. But the angle is half of the sum of the arcs that are intercepted. So looking at angle 1, we've got these 2 arcs that it intercepts. And the reason why you're adding them is because angle 1 is a vertical angle to this opposite angle right here. So it doesn't matter if it's intercepting this one or this one. It's kind of like taking the average of the 2. So we would say measure of angle 1 is equal to 1/2 of the 2 measures of the arcs. So measure of arc AD plus measure of arc BC. And then for number 2, you would do the same thing, except we would have to take 180 minus angle 1. You can do AB and DC for that one, or you can just do 1/2 of, or 180 minus that. That's what I would do. So there's 2 formulas. 1/2 of AB is the one that it intersects. And then DC is the other one. You could also say that measure of angle 1 plus measure of angle 2 is equal to 180. So to find one of them, they're a linear pair, they form a line. To find one of them, you would have to subtract from 180. So we have a couple examples on this. I'll do 2 examples. Number 1, we are looking for AED. So we're going to find AED. That's this guy right here. The 2 arcs that it intersects, this one and this one, we would add them and divide by 2. So we're going to add 45 and 109. Get what you get in your calculator. And then divide it by 2. I got, when I added them, their sum is 154. Divide it by 2, and I get 77 degrees for that arc, or for that angle, I should say. Okay, let's look at another type of problem. Let's do like one like 6, because that one's not the same idea. So number 6, I'm looking for an arc, so I'm looking for QT. I would highlight that or bold it with your pen. I'm going to highlight it as well with a marker, so it makes a little bit, a little bit more sense. So QT is what I'm looking for. I want to find the angle that it belongs to, and I'm looking at it, and I believe I would not use 79, but I would use this one. So this is my angle that it intersects. So that angle is QUT. QUT. So let's find measure of QUT. because I have its supplement, the angle that's right next to it, I would just do 180 minus 79. And I get 101 degrees. So both of these angles right here at angle U, the ones that are across from each other that open up to QT and RS, those are both 101. So remember that our formula is the angle is equal to 1/2 arc plus arc. I'm going to use this variable x. You can use any variable. You can use the letters Q and T. I'm going to use x. And I'm going to say the angle 101 is equal to 1/2 the two arcs. So x plus 95. Now, I don't want to deal with 1/2. So the other formula we can remember is to double the angle equal to the arcs. So I can multiply both sides by 2. That gets rid of the 1/2. It gets rid of the 1/2. It moves it over to the other side. 101 times 2 is 202. And then x plus 95, we would just subtract by 95. Which, that's 100 and something. I'm going to use a calculator. I get 107. Yeah, that makes sense. So x, which is QT, measure of this arc, is equal to, I got 107. Okay, so we're on to the second case, and the second case is where it's on the circle. This one I love because it's very similar to inscribed angle. So if you want to look back at inscribed angle, you can. There we go. So I think inscribed angle. So the rule for inscribed angle is that it is half of the arc. So we're going to look at the angle. Angle 1 is equal to half of the intercepted arc. So it's equal to the arc AB. You would name it AB because there's no other point in between A and B, and it appears, we're going to make that assumption, it appears to be less than 180. So it's a minor arc. So it's just 1/2 of the measure of AB, that arc. Easy peasy lemon squeezy. And then measure of angle 2, same thing. You don't have multiple arcs, you have just the one angle that I'm dealing with. It just depends on what it opens up to. So we would say 1/2 of measure of, in this case, we would be BCA or ACB. Because it is major, we would need 3 letters to describe that one. But same idea, angle is equal to half of the arc. You would double the angle to equal the arc. It's the same exact thing as inscribed angles. So let's do 2 examples here, maybe 3. One that is an angle, maybe one that's here, and then one down here that is algebra. So let's do number 8. I think that's a good one to try. So DBC is what we're looking for. That's this angle right here. There's multiple ways to do this. We could find, I see this arc, I could find the supplement to that angle and then subtract by 180, or I could find the other arc and subtract from 360. Oh, I should go back and say that measure of angle 1 plus measure of angle 2 equals 180, because that will come in hand. And then also the arcs both add to 360. Anyways, I'm getting ahead of myself. Let's focus back on this problem. So I'm going to find this arc and then divide by 2. So 360, that's how I decided to do it. It could, you could do it a different way. 360 minus 192, I get 168. And so that's the other part of this arc, because the whole thing is 360 and this is a tangent. And this guy is known as a secant or a chord because it goes outside the circle, but it's, it's a secant. We're going to divide that by 2 to get the angle. So measure of angle DBC is 168 divided by 2. 84 degrees. And that's it. And let's see if we have, these are like a mixed bag of problems actually. So let's do one of these first. So that was where I had the arc. Let's do one where I have the angle and I need the other arc. So I have JKM. I have this little bit is 23. And then I am looking for KNM. So I'm looking for this guy right here. I'm going to go ahead and double it and get KM and then subtract from 360. And that's really the first thing that I thought of. You could do 180, subtract 23, and get this bit. So this little chunk right here is 46 degrees on the arc. Do 360 minus 46. I get 314. And that is for K and M for that arc. And then these guys are just algebra versions. We'll go back over that after doing the backside for the last case. So the last case, we have 3 little types where we have an angle outside. So we have this angle, and this angle. So I put a little angle 1 or angle A, you could always say. So we have the case where we have 2 secants. So basically we have these 2 parts. We take the outside arc and minus the inside arc and then divide it by 2. You're going to do the same thing for the tangent. Take the outside arc minus the inside arc and divide it by 2. And then the angle outside arc minus inside arc and divide it by 2. So for this one, you just really think angle is equal to 1/2 outside arc minus inside arc. And then just divide it by 2, or 1/2 of that. So for this one, measure of angle A is equal to CE minus BD divided by 2, or 1/2. 1/2 measure of CE minus measure of BD. A is equal to, in this case, BD is my outside arc. So 1/2 of measure of BD minus BC. Because they have that one bit in common right there, that angle B in common. And then this one is kind of weird. We have this whole thing and this whole bit. So we're going to take the whole outside arc. So 1/2, oops, I forgot the measure, the little m. Just looking back at my previous problem. 1/2 of the measure of ADC, BDC minus BC. And the fun thing about this is these 2 bits should form a full circle, which is 180 degrees. So let's get to business. So let's do one type of every problem. So we have 2 secants here, 2 secants. We have a secant and tangent. So tangent is here and a secant. And then we have secant and a tangent. And then we have a secant and a tangent, and then 2 tangents. So we definitely want to do one of each problem. Let's do the 2 tangents. Let's go ahead and just do the even ones on this. Okay, so BCD. BCD is this angle, and I see that this guy right here goes through the center. So that tells me that this whole thing is 180 degrees, and I need to know that to find the missing arc. Because I don't have the angle, I do need to solve for the angle, and I need this arc bit. So I'm going to add these two together and get the part of the arc that I do have. I get 161, and then subtract it from 180, because that whole thing is 180. And now there are always more than one correct way to do these problems. This is just the way that I saw it. I first noticed that this was a diameter, and I related it to like a semicircle, which is doing 180. Okay, this bit right here is 19 degrees for that arc. Remember the formula for when it's outside, you do the outside arc minus the inside arc and divide it by 2. So the angle is equal to BCD is equal to outside arc minus inside arc divided by 2. There we go. 67 minus 19 got me 48. And then 48 divided by 2 gets me 24. So that's my answer for number 12. Okay, here we go. For number 16, let's see what we have. I believe this bit is showing me as 62, and this bit is 88. And again, I'm looking for ABC, so I'm looking for this angle. We would figure it out the same way. Add the two bits, only this time we're using the whole circle, which is 360 degrees. So we're going to take 88 and 62, and we're going to subtract it from 360. Add them together. I'm going to do it in one fell swoop on my calculator using the parentheses. I get 210. So that's the outside arc. Remember the formula, outside arc minus inside arc divided by 2. So my angle ABC is equal to outside arc, inside arc, subtract them, divide by 2. I got 148. And that should divide nicely. Even if it didn't, that's okay. We can have decimals. I get 74. You can see on my calculator all my work. So I'm doing these problems with you. Okay, for 20, I love two tangent problems because they really give you nothing, which is super helpful. But you are given as much information as you need. No more, no less. So I have the inside arc. To find the outside arc, that major arc right there, we're just going to take the sum of a circle, which is 360, and subtract the bad boy that's inside, 106. And that gets us our outside arc. These ones always seem harder than they actually are. They're not that bad. So I got 254. Remember, same formula. Make sure we're solving for the same angle, ADC. No, CDE. Oh my goodness. And we're doing outside arc minus inside arc. Divide it by 2. And I get 74. I'm going to stop the video here since it's getting long and do 3 examples with the algebra on the other side of this page.